Hello, this video will discuss something called TLS harvesting, some people call it SSL harvesting, and the way that Phio TX can address that threat. So what I have here is a network, and I'm going between my headquarters and data center or cloud, it doesn't really matter, and I want to encrypt the data that's going between the two, and I'm going to use a high-speed line encryptor in this case. So I have a tunnel, and I'm going to create the tunnel between these two devices. Now, to do that, these devices use public key encryption, which is actually vulnerable to a number of things, not the least of which is the impending quantum computing capabilities, which will break public key encryption. And the other challenge is architecturally, there's one network to monitor here. There's one connection to monitor to get both the key and the data. And we believe that that's really the root of the problem. And so what happens is an attacker starts tapping the network. It can't be stopped unless there's physical security along the entire length of the network, which there really isn't. And so now they start tapping the network and they're looking for a handshake. And in that handshake, what happens is an encryptor will generate a key. It will wrap it in a public key envelope. It will send it to the other side. The other side has a private key. This is an RSA example. And now the tunnel is encrypted with an AES key, which is AES encryption is basically immune, or it's only slightly weakened by quantum. And so now the attacker, though, has a copy of that key in its envelope. He can't do anything with it yet, but he has a copy. And now he starts copying all the data that goes through there. Remember, there's one session to monitor, and so I get the key and all the data. So they have an encrypted copy of the data. Anything in the tunnel is encrypted. It's magically decrypted when it's on either side. And so now they have both. Over time, they break that key. Could be because there's poor entropy on the key, could be because they've got a quantum computer, could be some other way to do it, but they break that public key. And once they do that, they can decrypt the session key. And when the session key, they can replay the data they stored cheaply in Amazon or some other cloud service, and they get the actual copy bit for bit of all the data that was sent between the two. And that's because we send the key with the data. And if you change this to some other new quantum resistant algorithm that does the same thing but in a quantum resistant way, well, you have the same problem. You break it, you get everything. So at Quantum Xchange, we think that there's a better way to do this. So we're going to keep everything else the same. It's the same encryptors. It's the same network. If you have route diversity, all that stuff stays the same. But now we add Phio TX. And Phio TX gives you an out-of-band way to send a key between two locations. And there can be intermediary devices between these Phio TXs. So you have a hive and there's key routing and other things that make it even more difficult for the attacker. So in this case, I'm going to send a key between the two. Again, could go over an intermediary route. It's a quantum key. It'll be QRNG based or QKD based, depending on what your network looks like. And I have a quantum key that's delivered to both sides. And that's known only, it's done using quantum safe technologies like post-quantum crypto or QKD. And it's known only now to the encryptors at both sides. What the encryptor does with it is known only to the encryptor itself. And that's really an important concept to understand. So now the encryptor takes it, and rather than encrypt data, they encrypt the key that they send. And then everything else works the same. They take the session key, they wrap it in an envelope, they send it to the other side. It's decrypted with the private key, then it's decrypted with the quantum key, and that session key, which is known only to those two encryptors now, is what's used to create the tunnel. Now the attacker has a copy of the key, but it's a key they think decrypts the data. It's an encrypted key. Now data goes through, everything else works exactly the same. The attacker gets a copy, he's spending time and energy and money to do this, and at some point when they break that public key envelope, what happens? Well, they have an encrypted key that doesn't yield any data. So that's how Phio TX prevents TLS harvesting. And what we've effectively done is that we've taken the entire length of the network, which is the current threat surface, and compressed it to this encryptor. If you can't get inside the encryptor, or this one, if you can't get inside the encryptor, you can't get the data. And if you could get inside the encryptor, you wouldn't mess with the keys, because on one side of the encryptor is encrypted and the other side is pure clear text. So breaking into the encryptor and stealing the key would be like breaking into a bank vault and turn around and see how the lock works. If you broke into the bank vault, you'd take the money. So that's how Phio TX prevents TLS harvesting in a really simple overlay network. Thank you.